So, dito na tayo sa may 25 dyan sa inyo, 24 dito sa akin. So, as you could see, we're still on time, yung redox and electrochemistry. Baka matapos natin yung electrochem ngayon. And then, if you want to meet next, no, we will meet next meeting. Kung may tanong kayo, tanungin nyo. And then, 28 to 30, you will have your departmental module. Tapos, next week, we will have the chemical kinetics. Okay? Tapos, June 8. So, bilang na araw natin, mahalos matatapos na tayo sa klase natin. Okay? Now, I'm not going to give any quizzes because alam ko, hirap na kayo doon lang sa module requirements. But I would suggest go over the course pack. Tapos kung may tanong kayo, pwede kayong mag-email or pwede nyo akong hanapin doon sa Facebook if you want to send message. I'm okay with that. Okay? I'm here to help you. Okay? Now, the only thing I can help you is to prepare you for the material. Kasi nakaset na lahat eh. Okay? Ang style nila is you read the module and then yung session na ganito is more on clarification. So, ang gagawin ko lang, mag-a-add lang siguro ako, ika-clarify ko lang, sabi ko nga, supplemental. And if you have looked at our Google Classroom, so you see I have two sections, so you are this one. So I already input the recordings, and in addition to the session that we have, meron na nilagay ko dito yung direct link doon sa mga topic. So kung meron kayong enough bandwidth or enough time, you feel free to watch them. Okay? So kung hindi nyo kayang maano, kung napapanood nyo to, it's fine. Naintindihan ko naman yung sitwasyon nyo eh. Kaya nga sabi ko sa inyo, if you can email me, if you have any question, I'm more than happy to answer any question. Naintindihan ko yung sitwasyon nyo dyan. Kaya hindi ko nire-required na ano. Ang ano ko lang, minsan nahuhuli yung pag-upload ko. And sometimes it took me Friday here, na dyan Sabado na. Okay? So, this is the recording that we have. So, this is our 5th meeting. Tapos kung gusto nyo, so ang ginawa ko to make sure na hindi masayang yung gastos nyo, I may have the same explanation but I try to make the problem different. Para naman sulit. Okay? Tapos yung kinetics, nuclear chem. Okay? So we started already with what we call redox. So as of now, may tanong ba kayo doon sa tawag nating oxidation number? Do you have any question with the oxidation number? Huwag mahiya. Yun yung role ko to make sure that you understand the concept that we have discussed. Okay, so as I have told you, the oxidation number, the knowledge of oxidation number is needed kasi yung change in oxidation number ng element, yun lang makakapagsabi sa inyo kung meron kang redox reaction. Okay, remember, redox reaction is just what? Electron transfer. So one element loses electron, another element gains that lost electron. And the only way for you to determine if there's a redox reaction is if there's a change in the oxidation number. So you still remember what I asked you? The Leora and Jajeroa, tandaan nyo pa yun? So if you lost electron, that means you undergo oxidation. And you serve as a reducing agent. Now, if you gain electron, that means you undergo reduction. That means you are the oxidizing agent. Tingnan ko yung course pack ninyo, but I think we already answered some of the questions, yung tinatawag na SAQ from last meeting. Okay? So I think you are already what we call done to this what we call concept. Okay, and then we also have an example of balancing redox equation. I'm not sure if I put another one here. So I have here this one. So maybe nasa recording, this is in the recording of my what we call PACE lecture. So you can look at this. Maybe ang gawin natin ay ibahin natin. Tingnan natin yung SAQ question ninyo. So if you want to answer this question, pwede nyong tingnan doon sa lecture ko, doon sa PACE. Okay? So, ang gagawin natin ay yung nandoon sa course pack. So you have copper plus H plus NO3 producing copper 2 plus NO2 plus H2O. So anong gunaan na natin gawin? So ang sabi dito, balance the redox reaction using the change in oxidation number method. Identify the reduction half reaction, oxidation half reaction, reducing agent, and oxidizing agent. So ano muna natin gawin? Anyone? Huwag mahiya, magsabi. Hindi na lang magpaalam. Anyone? Ang una natin gagawin, assign natin yung oxidation number. So ito ay 0, right? Ito ay plus 2. Ano ang oxidation number ng H+?
1 po.
Okay, positive 1. Eh, itong H dito sa H2O. 1 din ba? 1 din. Tapos yung oxygen dito ay 2, negative 2. The same thing here. So ano ngayon yung oxidation number ng nitrogen dito? Anyone? So
6 po. 6.
So ano yung charge ng NO3?
0.
0. So sabi natin, yung oxidation number, okay, i-multiply natin sa number ng element, tapos i-add natin doon sa oxidation number times the number nung isa pang element, i-add natin lahat equals the charge. So if this is negative 2 times 3, that will give us negative 6. So this is positive 6. So the same thing dito, this is negative 2. So yung N mo ay, ano? Oh no, wag ka naman tumugtog.
2 po.
Okay, is it 2? Negative 2 times 2 will give you what?
4 pala.
4.
Okay lang magkamali ngayon. Wag lang sa exam. Sarap ko lahat. May maingay na mga ano dito. Kapitbahay. So, ano ngayon yung OHR? Ano ngayon yung RHR? Or before we can do that, ano yung reducing agent? At ano yung oxidizing agent? Or paano nyo gusto? Malaman mo na alin yung na-oxidize at na-reduce, tapos mapipredict nyo alin yung reducing agent tsaka oxidizing agent. Okay? So ano yung nag-oxidize? Is it copper or nitrogen? Anyone? Ano yung na-oxidize? So 0 to 2, tapos yung isa 6 to 4. So most likely, ito yun. It becomes more positive, so that means it's oxidized. Tapos yung isa, literally, yun yung name, reduce. Okay? So na-reduce yung oxidation number. So in that case, what is your reducing agent? Is it copper or NO3?
NO3.
So remember the Leora and the Geroa? Okay? So the one that is oxidized, that is your reducing agent. And the one that is reduced, that is your oxidizing agent. Does it make sense?
Copper po.
Ha?
Yung copper po.
Yung copper ang reducing agent mo. Usually, ang guide mo, kapag reducing agent ka, usually yun metal. Tapos kapag oxidizing agent ka, yung may oxygen. Usually yung mas marami ang oxygen. Okay? So yan yung guide. Kapag hindi mo alam. So oxidizing agent. So obviously, meron siyang oxygen. Kasi ang oxygen ang mag-oxidize doon. Okay? And look what happened kung oxidizing agent siya. Yung NO3 nagiging NO2. Bumaba yung number ng oxygen. Okay? Now, how are we going to continue on? So based on our what we called, what we have learned last meeting, we can balance the element on both sides. So here copper and copper are the same. Then the next thing that we're going to do, there's a positive 2 here and then there's a 0. So that means dadagdagan mo siya ng dalawang electron. Okay? And then I can expand this. So remember, there's a water there. Okay? Kasama yun doon. Now, is this water enough to balance the oxygen on both sides? So tatlo yung oxygen mo dito. Sa pagdagdag ng isang water, naging tatlo din. Yung nitrogen tig-isa. So ibig sabihin, may dalawa kang hydrogen na dagdag. So, dadagdagan mo lang to ng dalawang H+. Now, as you could see, walang charge dito sa product side, may dalawang charge or positive 2 charge dito. So para mabalance siya, dadagdagan mo ng dalawang electron. Now, since pareho na yung electrons na nawala at na nag-gain, so ibig sabihin, pwede mo nang i-add yung dalawang half reaction. Okay? So, kapag nangyari yun, just bring down everything. Now, to check kung ito nga yun, you have to make sure yung elements sa both sides ay pareho. Isang copper, dalawang H, dalawang H, isang nitrogen, tatlong oxygen, dalawa at saka isa, tatlo. And then yung charge, H plus H plus plus 2 dito, tapos plus 2 din dito. So this is in acidic solution. Now, if you want it to be in basic solution, anong gagawin natin? Dadagdag tayo ng ano?
OH, sir.
Dalawang OH sa both sides. Bakit dalawang OH? Bakit dalawang OH? Anyone? Paki-explica. Tagal ko na hindi nagamit yung salitang yun. Paki-explain. Bakit dalawang OH? Kasi meron kang dalawang H plus dito. So, kapag dinagdag mo ng dalawang OH, ito ay magiging dalawang tubig. So, mawawala yan kasi magiging tubig na siya. So, may dalawang tubig dito, may isang tubig dito, mawawala to, ito magiging isa na lang. Tapos, ang mangyayari, titingnan mo uli kung balance sila. Copper, copper, N, oxygen, tatlo dito, isa pa, so 4. So, dalawa dito, tapos dalawa sa OH. Tapos hydrogen, dalawa dito, dalawa dito. So, pareho na. Yung charge, 0 dito sa side na to, plus 2 and negative 2 dito. So, ito na ngayon yung basic solution. Tanong. Bago tayo pumunta sa cell.
Answer.
Kung ganito ba yung mga estudyante ko dito sa US, hindi na mamumuti buhok ko. So, punta nga tayo ngayon dito sa tinatawag na electrochemical cell. So, sabi nga natin yung basis ng electrochemistry redox reaction. Okay? At yung product ng electrochemistry itong tinatawag na electrochemical cells. So, dalawang type yan. But if you're going to look at the electrochemical cell, this is a system consisting of electrodes that dip into an electrolyte and in which chemical reaction either uses or generate an electric current. So it's either uses or produces an electric current. So yung nag-produce, yun yung tinatawag nating voltaic or galvanic cell. So this is an electrochemical cell in which a spontaneous reaction generates an electric current. Okay? So ito yung nagpro-produce ng energy. Classic example, anyone? Anong classic example ng voltaic or galvanic
Battery.
Battery. And the name itself is named after some scientists, Alessandro Volta and Luigi Galvani. Now, yung isa namang type ng cell na kung saan kailangan mo ng electricity para magkaroon ng reaction, yun yung tinatawag na electrolytic cell. So ito yung electrochemical cell in which an electron current drives an otherwise non-spontaneous reaction. So kailangan mo mag-apply ng energy para ang reaction ay mag-happen or mag-occur. Yun yung ano nung dalawa. But they have common stuff in them. They always have an electrode that is deep in an electrolyte. Okay? Yung tinatawag nating electrode, okay, usually it's a metal. And kung ano yung metal, nakadip siya doon sa ionic form ng metal. So if you have here, you have a zinc metal that is deep in zinc 2+. And then you can have a copper metal that is zinc in copper 2+. Okay? So in a typical electrochemical cell, usually it's made up of 3 components. Ang tawag namin dyan is ABC. Okay? So anong ABC? You have an anode, a salt bridge, and cathode. Okay? And usually, electron flows from A to C, alphabetically. Okay? Now, you will learn the role of the component that we have here. So, si anode, dyan nagtitake place yun, oxidation. Irregardless whether you have a voltaic cell or electrolytic cell. Ang anode ay ang electrode kung saan nagtitake place yung oxidation. Meron pa ba to sa English ninyo? How do you know that? Vowel to vowel, consonant to consonant, right? You know the vowel to vowel, the A, E, I, O, U? Anode oxidation, cathode reduction. Okay? So electrons would flow through the external circuit from A to C, alphabetically. Okay? Now, ano naman yung role ni salt bridge? So yung salt bridge, ang ano nito is this is just a tube of electrolyte in a gel or a solution that is connected to the two half cells of the voltaic cell. And what it do, it allows the flow of ions but prevents the mixing of the different solution that would allow direct reactions of the cell reactant. Sabi dito, sa salt bridge, yung cations move towards the cathode and the anions move toward the anode. The question is, bakit? So let's try to look at a specific galvanic cell. Okay? So ito yung tinatawag nating copper zinc galvanic cell. So usually, since this is a galvanic cell or a voltaic cell, it happens spontaneously and it generates energy that you can call cell potential, cell voltage, electromotive force. Okay? So if you're going to look at this, this is the anode, this is the cathode, this is the salt bridge. So if you're going to look at the overall reaction, this is how it looks like. Now the question is now, which is which? Alin dito yung anode, alin dito yung cathode, or alin dito yung oxidation half reaction, at alin dito yung reduction half reaction. Okay? So, the concentration of both electrolytes there are both 1 molar. And if you're going to look at here, okay, this is the so-called cell diagram. So, balik tayo doon sa previous slide. So, tingnan natin alin si anode, alin si cathode. So, si anode, ano nangyayari? Si anode ay, oh no, lumaki. Paano ba yung palilitin? Daan yung oxidation. So sa tingin niyo ano mangyayari? Let's say zinc yun nandoon. Paano yung arrangement nito? Yung zinc mo, ma-oxidize to zinc 2+. Yung copper naman, yung copper 2+, magiging copper metal. Now, knowing that thing, okay, at sabi natin magta-travel yung electron from here going here. So ano ngayon magiging charge dito? Positive, negative?
Negative.
Negative. Ano naman yung magiging charge dito?
Positive.
Positive. Nawala yung electron, naging positive. Yung electron pumunta dito, naging negative. So, mangyayari ngayon, okay, papasok yung role ng salt bridge. So, hindi pwedeng magiging negative ito at ito ay magiging positive. So, what the salt bridge will do is it going to maintain the neutrality. So, since ito ay what we call positive and negative, so ito yung cathode, right? So, pupunta dyan yung, so this is negative, pupunta dyan yung positive charge. Kaya nga sabi dun, the cation ions will go to the cathode. Why? Because it tries to maintain neutrality. So ayaw niya being negative lang dito. Kasi na-accumulate yung electrons. Now on the other hand, since positive itong side na to, so the anions will go to the anode. Now this happens both in voltaic cell and electrolytic cell. So that's the role of the salt bridge. It maintains the neutrality. So how do you maintain the neutrality? So kung saan yung negative charge, mas madami pupunta yung cations doon, which is positive charge. Kung saan yung positive charge, pupunta doon yung anions ng salt bridge. The salt bridge is made up of salt. So you always have a positive and a negative cation. So question so far, yun yung basic ng galvanic cell. Now you may ask yourself now, so ito yung na-oxidize, ito yung na-reduce. Okay? If you're going to look at the oxidation half reaction, you could say it's zinc producing zinc 2 plus 2 electron, and then the RHR will be copper 2 plus 2 electrons producing, no, not copper 2 plus, copper. So if you're going to cancel out the electron there, yung overall reaction nito ay yung nakasulat dyan. Now there's a shortcut there. Okay, you can write it in terms of cell diagram. And what you do, you follow A, B, C. You write the anode in the way that you have this. Kita niyo yung magkasunod? It's just based on this, reactant product. And since there's a difference here in terms of the physical states, lagyan mo yung, ano ba tawag dyan? Line. Hindi ko alam kung horizontal or vertical. Okay? Now, kapag double line, it represents your so-called salt bridge. So, you're going to look kung ano yung reactant dito, product. So, left to right. Tapos kung ano yung reactant dito, which is copper 2 plus, and then you put the product on this one. And if you have an electrolyte or solution, you might as well put the concentration. So question. Now, ang tanong naman yan Sir, paano po natin nalaman na yung zinc ang magiging anode at yung copper ang magiging cathode? Meron ho bang rule kung sino ang magiging anode at sino ang magiging cathode? And the answer is yes. Okay? Diyan yung pumapasok yung tinatawag nating reduction potential. So anong ginawa nila? So what they did is they measured each metal in its respective electrolyte and combine it with the standard. Ano yung standard nila? Hydrogen electrode. In some, they call it what? SHE. Okay? So, pag sinabi mong standard, so it refers to the condition of 25 degrees Celsius, 1 atmosphere, and 1 molar electrolyte concentration solution. So in this case, if this is your what we call cell diagram, so ibig sabihin ito yung anode mo, ito yung cathode mo. Now in this case, we could say this is the reaction that happens there. Hydrogen ion producing hydrogen gas. So kung isusulat mo yung half reaction, nung oxidation is still zinc to zinc 2 plus 2 electron. Now for the cathode is 2H plus 2 electrodes to produce H2. So lahat ng metal, mineasure nila yung potential nila against this one. So yung hydrogen, standard hydrogen electrode, yun yung we could say point of comparison. And when you place them, okay, with let's say a metal, which in this case is zinc, magbibigay siya ng reading. Ngayon, itong reading na to, meron siyang tinatawag nating cell potential na lalabas. Okay? So in the standard reduction potential, that's the voltage associated with the reduction reaction at an electrode when all solute are 1 molar and all gases are 1 atmosphere. So ito yung reduction reaction niya. And they assign it an electron potential, reduction potential of 0. Now ang tanong, bakit 0? Why do you think they assigned the 0 number, not 1, not 2? Anyone wants to answer? Sa tingin nyo, bakit 0? So kapag binaliktad ko itong reaction, ano sa tingin niyo yung reduction, yung potential nito? Ano yung tingin niyo yung potential niyan kapag binaliktad ko? Anyone? Anyone wants to guess?
100%.
It's 0. Kaya nila inassign na 0 kasi baliktarin man nila yung potential, whether it is a reduction potential or oxidation potential, it's equals to 0. Okay? Kasi naisip nila, pwedeng yung ibang metal mas malakas or mas mataas yung reduction potential kaysa sa SHE. Pwedeng mas mababa. So, anong ibig sabihin nun? So, pwedeng magkaroon ng reduction or oxidation yung hydrogen electrode. Depende dun sa metal na pinipartner sila. Yun yung basis kung bakit 0 yung standard conditions na ginamit nila dito sa standard hydrogen electrode. So if you look at the standard hydrogen electrode, wala siyang metal na hydrogen. So meron siyang tinatawag nating platinum electrode. So pag ginawa mo sa cell diagram, nakikita mo merong platinum doon. But it's not part of the reaction. Okay? Inert yung platinum doon. So ito yung basis. At dahil dyan, so pag kinompare, yung tinatawag natin, pag kinombine yung zinc electrode sa hydrogen electrode, may reading na 0.76. Now, ang tanong niyan, okay, ito yung way para ma-determine nila yung reduction potential ng zinc 2 plus 2 electrons to give you zinc. Why? Kasi meron silang ginamit na the cell potential is equals to kung ano yung reduction potential nung cathode at ano yung reduction potential na nasa anode. So based on this one, alin yung alam na natin? Dito sa tatlong to, alin yung alam natin yung reading? So alam natin ito kasi nandito, di ba pareho sila? So this is what? 0.76. Alam ba natin to? Hindi. Pero alam natin to. Anong value nito?
0.
Okay? So we could say that's the E cathode equals to minus 0. So ibig sabihin, madidetermine natin ano yung reduction potential nito. Ito yung kinukuha natin. So if we rearrange it, what will happen? E cathode will be equals to, so 0.76 equals to E cathode minus 0. Is this how we do? Teka, tingnan. Ako kaya tayo nagkakamali. Check natin uli. So E cell is 0. Right? Alin yung anode, alin yung cathode? Ang kamali yata ako. So ito ay 0.76. Ang E cathode is 0. Tama? So E cell, E cathode. Bakit nasabi kong 0 to? Kasi, alin ang nag-reduce? Hydrogen or zinc?
Hydrogen.
Hydrogen. So yun yung 0. Ang hindi natin alam ay ito. Okay? So kapag yan yung sagot, paano natin i-anode? So i-anode pag nilagay mo sa kabila, plus e-anode, tapos 0 minus 0.76, and that is equals to what? Negative. So ibig sabihin, ito yung reduction potential ng zinc. Nakuha? So anong main point dito? Kailangan malaman nyo alin yung na-oxidize, alin yung na-reduce. Yung E-cathode doon nag-reduce. Yung E-anode doon nag-oxidize. Paki-analyze.
Sir, lagi po bang 0 dapat yung E-cathode?
Nagkataon lang na 0 dito kasi yung cathode natin ay ito. Na ang reduction potential ay 0. Hindi yan lagi 0. Depende kung ano yung anode or cathode nyo. Nagkataon lang yung cathode natin ay yung hydrogen. Tingnan natin naman yung isa. What if ang pinair natin sa hydrogen electrode ay copper? Ito yung potential na lumabas. Kaso mo, anong problema dito? Okay? Kapag tinignan natin yung cell notation dito, ganito yung cell notation niya. Platinum, H2, 1 atmosphere, 2H plus, which is 1 molar. Tapos, copper, 2 plus, producing copper, May 1 molar din dito. So ano ngayon yung anode dito? Pag ganito yung cell notation mo. Tingnan mo sa previous one. Tingnan nyo sa previous one. Ito yung cell notation. 6 C2 plus H plus H2. Pero dito, ganito. Okay? Platinum H2, H plus, and then copper 2 plus copper. So ano yung anode mo? Right? Gets ba? At yung cathode mo ay and you might ask, sir, ano ang basis nyo sa drawing? Left to right. Andito yung hydrogen electrode, andito yung copper electrode. So ang tanong dyan, alin yung alam natin dito sa value na to? Kasi ang hinahanap natin ngayon, ano yung potential ng copper 2 plus 2 electrodes producing copper. So hinahanap natin yung reduction potential niya. So ano yung alam na natin dito sa tatlo? Meron tayong dalawa na alam, yung pangatlo kukunin natin. Alam ba natin yung E-cell?
Yes, sir.
0.34, right? So alin dito yung alam natin? Yung cathode o yung anode?
Yung anode, sir. Kasi siya
Okay?
yung may
Ang alam natin
pressure.
dito, ito. Kasi siya yung
May
hydrogen.
pressure. Yes, yes, sir.
Okay? So ano yung value niya? Kasi pwede ko na isulat to as E copper 2 plus, okay? Copper, tapos ito naman, E, okay, of your H plus H2. So anong value nito?
0.
So 0.34 and then the reduction potential of the cathode minus 0. Why? Kasi hydrogen electrode siya. So if this is 0, ito yung reduction potential niya. So yan yung basics nung tinatawag natin reduction potential, which is this one. Babalikan natin yan kasi masyadong maliit eh. So maybe ito, pinalaki ko. Hatiin na lang natin. So ito yung 0. Ano yung tinest natin? Okay? We tested the zinc and kung wala dito or nandito sa ilalim. Ito. Now, anong ibig sabihin ngayon yan? Anong ibig sabihin yung reduction potential? So, babalik tayo dun sa slide kasi nandoon yung ano eh. Now, the reduction potential is for the reaction as written. So, anong ibig sabihin? Ano yung reaction? Okay? Kaya nga tawag sa kanya reduction potential. So, ibig sabihin, nasa form siya ng reduction reaction. So, ano ibig sabihin nun? Nasa reactant yung electron. Kasi nag-gain siya ng electron. Okay? Now, ang ibig sabihin din dito, the more positive the reduction potential, the greater the tendency for the substance to be reduced. So mas mataas or mas positive yung reduction potential, most likely marireduce siya. And then, reversible yung half cell reaction. At pag ni-reverse mo, okay, pwede mong i-change yung sign ng potential. Pero hindi mo natatawagan siyang reduction potential. Ang tawag mo na sa kanya ay ano? Oxidation potential. Kasi na-reverse eh. And most importantly, this is an internal property. So, ano man yung dami, okay, isa lang yung value ng reduction potential nito. Even if you change the stoichiometric coefficients of a half cell reaction, it doesn't change the value of the cell potential. Okay? So, ito na ngayon yung sagot sa tanong, Sir, bakit po yung zinc ang na-oxidize at yung copper ang na-reduce? Here, right? Palaisipan sa inyo, may basis ba kung bakit yung zinc ang na-oxidize at yung copper ang na-reduce? Tingnan natin yung reduction potential. Kaya hin-highlight ko yun eh. Masyadong maliit to. So look at the reduction potential. So this is 0.76 negative and this is positive 0.34. Anong sabi? The more positive potential, the more likely it will reduce. So anong ibig sabihin nito? So between the two, sasabihin niya sa zinc, hoy, mas malakas yung potential ko, mag-oxidize ka. Kaya ito yung naging anode. Tapos ito yung cathode. Now, kapag nag-oxidize to, pwedeng maging positive 0.76 to. But for simplicity, ito na lang gagawin natin ha. Kapag ang ginamit mo is cell potential, okay, pwede mo na lang ilagay kung ano yung potential na nasa cathode minus yung nasa anode without changing the sign of the one that oxidized. So lahat reduction potential. Ang kailangan mo lang gawin is ma-identify mo alin yung cathode, alin yung anode. So ano ngayon yung cell potential kapag itong dalawa ang naging part ng battery mo? Anyone? Anong ilalagay kong value dito at anong ilalagay kong value dito sa anode when we have a zinc and a copper voltage cell? Anong ilalagay ko sa cathode na value? I have a zinc and copper
Yung
voltage cell. Ano, Jovan?
Hindi ko po sure, sir. Hindi ko po sure, sir.
Ha?
Hindi ko po sure, sir.
Ano nga? Hulaan mo.
Yan po yung point. Yes.
Okay? So, ang ilalagay mo sa cathode ay yung nag-reduce. At yung na-reduce ay yung may mas positive na value. Tapos, ang ilalagay mo sa anode ay yung na-oxidize. But, hindi mo papalitan yung sign. You keep it in reduction form. And what happened? What's the value that you will get?
Positive 1.
I always taught this to my students. Na yung iba nalilito kasi, Sir, di ba yung anode nag-oxidize? So dapat maging reverse yung sign. Yes, but if you're going to follow that thing, maybe the appropriate formula for you is this. So anong ibig sabihin nito? Kung ano yung potential nung nag-reduce at i-add mo doon sa potential na nag-oxidize, which is usually the reverse kung ano yung reduction potential mo dito. Right? Kasi kung ito yung finalo mo, kasi nalilito ka, ganito yung kakalabasan niya. Now you might say, Sir, bakit naging positive to? Anong sagot nyo? Ang sagot nyo kasi nag-oxidize to. Saka pag nag-oxidize to, magre-reverse yung sign nito. Now, see the difference that I put here? I can have a cell potential wherein I just get the reduction potential of the anode or of the cathode, subtract it with the cell potential or the reduction potential of the anode. Or I can do it in such a way I get the reduction potential nung cathode, i-add ko yun sa oxidation potential nung nasa anode. Okay? We'll have more example on this, don't worry. So this one, ano mangyayari kapag nilagay mo yung molecular bromine doon sa solution na merong NaCl at NaR? So ano yung competing species dito? Br2, Cl minus, I minus. So ano yung kailangan mo para masagot itong tanong na to? Kailangan mo yung reduction potential. Tapos hahanapin mo nasaan yung mga species na yun. So wala ata dito kasi mas konti ito. Okay? Pero meron tayo dito. So hahanapin ngayon natin nasaan yung mga species na yun. So ito yung isa, Br2. Tapos hahanapin na yun yung Cl. Ang Cl nandito. Tapos yung I minus. Nasaan na yung I minus? Medyo malabo na yung mata ko.
Sir, nasa gitna po.
Anong number? I mean,
Ay.
ito. Tama. Ayan. So ano ngayon? So sino ang magpapabago sa bromine at sino ang hindi maapektuhan ng bromine? Yung reduction potential yung guide. Okay? So makikita natin kapag sinulat natin isa-isa, so we have Br2 plus 2 electrons, magproduce siya ng 2 Bri, right? Tapos ito naman, pwede natin isulat to na ganito. And then this one, and all we need to do is get the cell, reduction potential. So tingnan natin. So meron kang 1.36, 107, tsaka 0.53. So, ano mangyayari? With the reduction potential as our guide, what will happen? Alin ang pwedeng i-oxidize ng bromine? Kaya ba niyang i-oxidize ito? Between the two. Maapektuhan ba ng bromine yung chloride? So between the two, most likely ito yung ma-oxidize. Ito yung marireduce. Gets nyo kung bakit? Because this one has a higher reduction potential than this one. Sabi niya, kung sino yung mas positive, siya ang ma-reduce. Kung sino yung mas na negative or mas mababa, siya yung ma-oxidize. So ibig sabihin, hindi maapektuhan yung chloride. Pero between sa dalawang ito, anong mangyayari? Alin yung magre-reduce?
Yung bromide, sir.
Okay? So ito yung mare-reduce, ito yung ma-oxidize. At kapag nag-reduce ka, you are on the original form. Now, kapag ni-oxidize ka, you are in that form, 2i minus producing I2 plus 2 electron. Kasi ang original form ng iodine, ang I dito is in the I minus. So, ibig sabihin, yan yung maapektuhan ng bromine. So if you're going to look at the reaction, ano yung reaction mo overall? Your bromine will oxidize your iodide to give you 2 bromide and iodine. Medyo naintindihan ba? So anong basis ko dito? Yung reduction potential. So pag mas mataas, you will remain in reduction form. Yung mas mababa, yun yung ma-oxidize. Analyze before we go to another problem. Here's the next one. Meron kang galvanic cell na magnesium na nasa magnesium nitrate solution at silver metal na nasa silver nitrate. So ang sagot sa iyo ay ano yung electromotive force. So anong una mong gagawin? You write the reduction potential, the reduction reaction. And then, punta ka doon sa table, hahanapin mo ngayon yung magnesium na reduction potential tsaka silver. So you have negative 238 tsaka 0.80. So alin yung mag-oxidize, alin yung magre-reduce? Or I could say, ano yung nasa anode? At ano yung nasa cathode? Anyone? Alin yung reaction na magre-remain na ganon? Alin yung babaliktad? Anyone? Alin ito? Sa dalawa?
Sir, yung ano po, yung silver, yung cathode.
Okay, ito yung cathode. So that means it will remain on that form. Why? Bakit? Kasi mas mataas yung kanyang reduction potential. Tapos yung isa naman, babaligtad. So based on it alone, you can get the cell potential. Gamitin nyo lang kung ano yung nakasulat dito. Identify nyo ano yung cathode. So this is what? 0.80 minus negative 2.38. So ano makukuha nyo?
$3.18, sir.
Now, yung overall reaction, ano ngayon yung overall reaction dito? Mag-multiply ka ng 2 para ma-match yung number of electrons. So, maka-cancel yun. So, you have magnesium plus 2 silver ion producing magnesium 2 plus and 2 silver. I-analyze. Kung may tanong, magtanong. Almost maano na tayo dito sa part na to. Tanong, yung iba, yung 6 na nandyan, may tanong? Now,
Wala naman, sir.
so, may concept tayo na spontaneity. Hindi ko alam kung na-discuss nyo na yan. Alam niyo ba yung term na spontaneous?
Sir, mas nagiging random towards randomness.
Na-discuss nyo ba yung dito sa Chem 18? Doon sa thermodynamics?
Yes, sir.
So pag sinabi kasing spontaneous, kusang nangyayari. It happened on its own without outside intervention. Right? Kahit anong gawin mo, mangyayari at mangyayari siya. Classic example niyan, failing an exam. Right? Wala kang ginawa. Mag-e-exam ka. Papasa ka ba? You agree that failing an exam is a spontaneous process? You wanna try? Huwag kang mag-aral para sa quiz nyo. Ano mangyayari spontaneously? Most likely, babagsak ka. Okay? So, yung dinidiscuss natin about voltaic cell, all of them are what we call spontaneous reaction. So when we say spontaneous reaction, it happens as written. Now, I'm not sure if you already has this concept of delta G. Please let me know. Alam nyo na ba anong ibig sabihin ng delta G? Delta H is enthalpy, delta S is entropy, delta U or delta E is internal energy. But what's delta G? Anyone? That's the free energy or gives free energy. Okay? Now, sinasabi nila, kapag ang reaction is spontaneous, ang delta G value mo ay negative. Kapag ang reaction is non-spontaneous, ang delta G value mo ay positive. Now, we can relate your delta G with the cell potential. Okay? Ano dapat yung cell potential mo? Ang value ng cell potential mo when you have a spontaneous reaction is positive. Kapag negative yung value ng cell potential mo, ibig sabihin non-spontaneous yung reaction mo. Okay? Now, ano pa yung ibang info na meron tayo dito? N is the number of moles of electrons. Yun yung number of electrons sa reaction. At yung F, yung tinatawag na Faraday constant. Now, you can have a delta G that is non-standard or a standard delta G. Anong difference ng dalawa? This one, 25 degrees Celsius, 1 atmosphere, and if you have a concentration, 1 molar. That's the so-called standard condition. Okay? Now, we can also relate your delta G to this one. Ano ito? Delta G related to chemical equilibrium. So, anong ibig sabihin nun? Kapag spontaneous yung reaction mo, yung forward reaction ang magfe-favor or the reaction will happen as written. Kapag non-spontaneous yung reaction mo, the backward reaction is the one that is favored. So pag kinombine mo itong delta G na to in terms of chemical equilibrium and the delta G in terms of cell potential, you can come up with this overall relationship relating your cell potential with K. So ano ngayon yung relationship ng dalawa? Sabi natin yung delta G, negative siya kapag yung K mo ay ano, more than or less than 1. If you have a spontaneous reaction, what's the value of K with respect to 1? If delta G is negative. Ano yan? More than 1, less than 1, equal to 1. So usually more than 1 because the forward reaction is favored. There are more products compared to the reactants. At kung more than 1 dito, ibig sabihin your cell potential mo ay positive. And we can simplify the relationship here. We can put what? The R value is 8.314,298. That's the standard temperature. And then the Faraday constant, ang magbabago lang ay yung number of electrons. So if we're going to look at the number that will come up, either you use this or this. Depende kung ln of k ang gagamitin mo or log of k. But they will give you the same cell potential. And if we're going to summarize the reactions that we have here or the relationship that we have here, what does it mean? Once meron kang cell potential, you can get the K and the delta G using this different equation. And to end the lecture, yung sinabi ko kanina, yung relationship ng tatlo, pag negative yung delta G mo, your K is more than 1 and you have a positive cell potential. Kapag positive yung delta G mo, you have a non-spontaneous reaction, your K is less than 1 kasi yung backward reaction ang nagpe-favor. And you're going to have a negative cell potential. And if it's 0, delta G, you have a system at equilibrium and you have a dead battery. So dito mag-e-end yung lecture natin ngayon. Tatapusin natin next meeting. And I want you to prepare question with respect doon sa magiging quiz ninyo, departmental quiz. So tanong. Dun sa 6 na natitira dyan. Huwag mahiya. All I want is your success, okay? May tanong? Oliver? Jovan? Leo?
Wala naman po.
Sia? Alicia? And Joe. So, ang gusto ko, maghanda kayo para doon sa quiz. At kung may tanong kayo, you can email me at imohika@pace.edu or pwede natin pag-usapan on Thursday. Hindi ko alam kung excited ako or worried ako sa first quiz nyo under sa akin.